Ever wondered how Netflix knows what you'll binge next? It's clustering. Clustering is a machine learning technique that groups similar data points together without needing labels. It's unsupervised learning at its finest. From customer segmentation to image recognition, clustering helps uncover hidden patterns. But not all clustering methods are created equal. Let's dive into the most effective ones and when to use them. First up, k-means clustering. It's fast, simple, and works great when you know how many clusters you want. The algorithm assigns each point to the nearest cluster center, then recalculates those centers until things stabilize. But it struggles with irregular shapes and outliers. Use k-means when your data is well separated and you need speed over nuance. Next, DBSCAN, or density-based spatial clustering. Unlike k-means, DBSCAN doesn't need you to predefine the number of clusters. It groups points that are closely packed and labels outliers as noise. It's perfect for discovering clusters of arbitrary shape, but it can be sensitive to parameter choices. Use DeepScan when your data has noise or irregular cluster shapes. Hierarchical clustering builds a tree of clusters. It starts by treating each point as its own cluster, then merges the closest pairs step by step. The result, a dendrogram, a tree-like diagram showing how clusters form. You can cut the tree at any level to get your desired number of clusters. It's great for visualizing relationships, but can be slow with large datasets. Want something more flexible? Try Gaussian mixture models, GMM. Unlike k-means, which assigns points to one cluster, GMM gives probabilities. A point might be 70% in one cluster, 30% in another. This soft clustering is ideal when boundaries are fuzzy. GMM assumes data comes from a mix of Gaussian distributions, so it's powerful, but only if that assumption holds. Spectral clustering is the go-to when your data isn't linearly separable. It uses graph theory to map data into a new space where clusters are easier to find. Think of it as transforming your data into a new dimension where k-means can actually work. It's powerful for complex structures, but computationally heavy. Use it when traditional methods fail. So, which clustering method should you use? If speed matters and your data is clean, go with k-means. For noisy, oddly shaped data, DBSCAN shines. Want a visual hierarchy? Try hierarchical clustering. Need soft boundaries? GMM is your friend. And for complex, nonlinear data, spectral clustering is a game changer. The key is matching the method to your data's shape and story.